The torque tau on a body about a given fixed point is found to be equal to A and L. What is the meaning of A and L?
It was given A cross L in the solutions.
Typing mistake. Component of L in the direction of A doesn't change with time. There is A is a constant vector. Tau is the rate of change of L, na?
Yes, sir.
Is this rate of change of L perpendicular to A?
Yes, sir.
So how much component torque has along A?
0, sir.
So if torque has no component along A, will it change the angular momentum along A?
No, sir.
B is right or wrong?
Correct.
B is correct because the rate of change of L, which is the torque. This torque is perpendicular to A. So rate of change of L is perpendicular to A. No component along A. So no torque along A. So no angular momentum change along A. Along A, L remains constant. Any other doubt in this option? Any other option? Tell me.
So only the direction will change, the magnitude of the component will not change.
No, direction A is a constant vector. A is a constant direction.
L,
Whatever.
L's direction will change, but the component along A will remain constant.
Yes.
Sure.
Understood? Huh?
Yes, sir.
I'll give you example also on this. Let's talk about a conical pendulum. Tell me the angular momentum about point O and axis OC. Let's say this is ER and it's moving like this, and into the plane tangent is E theta, and this is axial.
About OC, it will be MVL sine theta in E theta. Sir. About O, MVL into cos theta and minus ER minus sine theta and the verticals. LOC is MVL sine theta in minus EA.
Why minus EA is coming?
I took the direction of velocity to be opposite. Sir.
Okay. So then should I put it plus plus here?
Yes, sir.
Now tell me the torque about O for this conical pendulum.
mgl sin theta.
Direction.
E theta.
Okay. Now let's talk about the rate of change of angular momentum about O. Theta is constant. If you differentiate it, what you will get?
M dv by dt into L.
V is constant. Let's say. Speed is constant in conical pendulum. One theta, one is speed.
Be 0.
This is changing or this is constant?
It is changing.
What is the derivative of ER vector?
V by L sin theta and E theta.
V by L?
Sin theta.
How you got derivative of ER as V by L? Ah, correct. V by L sin theta and E theta. Now this is constant. So this derivative is 0. Now this two should come out to be same. So where is the mistake here? There is no mistake. We have to find out the V, I suppose. So for conical pendulum, T cos theta is mg. T sin theta is equal to mv square by r. R is L sin theta. This is in E theta, mv and L cos theta sin theta. There is V here and there is a V here. So there is a V square. If you calculate dl theta by dt, and V square can be written as GL sin square theta by cos theta. So L gets cancelled, sin theta gets cancelled, cos theta. We get mgl sin theta and mgl sin theta. So there is a torque. Now let's consider this to be the A vector. If you consider this to be the A vector, then torque is perpendicular to A vector. Now, if along this direction is A vector, so A cross L if you do, so you will be doing EA cross ER plus EA. EA cross EA 0 and EA cross ER. This will give you E theta. That will give you the torque direction. So torque is equal to A cross L. So this component, this is along A vector. So this component of angular momentum remains constant. And the perpendicular component rotates. This component of angular momentum is rotating. This is the radial component. And to rotate, you need a tangential. So this is the torque. So this is how the torque of mg is about O. This torque of mg about O, this tangential torque, is changing this radial. Radial changes because of tangential. Like radial position vector changes because of tangential velocity. Like that. So this component rotates because of this torque. And this component of L remains constant. So this you can call it as the A vector. Are you understanding what I'm saying?
Yes, sir.